Hello guys, welcome to Rahul GPAT Academy. So today we are going to discuss regarding surface tension and interfacial tension, one of the most important topics for a GPAT as a NIPER point of view. Um, Minimum you will be getting like one or two questions from this topic, like surface tension as well as interfacial tension. From this topic, definitely you are going to get one or two questions. So let's see what the things are there. So surface tension. So what is surface tension? The surface tension is nothing but the force per unit length that must be applied parallel to the surface so as to counterbalance the net inward. So two terms in this chapter are there. One is surface as well as one is interface. So what is the basic difference between surface and interface? Now surface is nothing but the two different phase will be there, where one phase should be air or gaseous phase. One phase should be gaseous or air, that will be surface. An interface means between two immiscible liquid or liquid solid or two different phase. Okay, means if one phase is air, that will be surface. If it's two different phase like liquid or liquid solid, then it will be interface. So at the surface, whatever at the surface length, whatever tension or force applied, that nothing but the surface tension. Okay, that nothing but the surface tension, and that force applied, it should be parallel to the surface, parallel to the surface to counterbalance the net inward pull. Actually, whenever any particle is immersed in liquid system, each and every particle will be attracted by the surrounding particle. So what the particles are above or surface of any liquid system, that one will be put out inward. But as there is no particle at the above, that's why no outward movement. That's why it will be only having inward movement. But in case of interface, both the like in case of interface, so interfacial tension will be there, and that will be between different liquid, that nothing but the adhesive force, that nothing but the adhesive force. So surface tension is the indication of cohesive force. Surface tension is the indication of cohesive force. Okay. And what is the unit of surface tension? Now Newton per meter in SI unit. And in case of CGS unit, dyne per centimeter. That's it. And what are having surface tension of 72.8 dyne per centimeter. And already I told that interfacial tension is nothing but the force per unit length that existing at the interface between two immiscible liquid phase or liquid or solid also. Means here two different system will be there, two different phase will be there. That's nothing but the interfacial tension. Okay, and interfacial tension as between two different liquid, immiscible liquid. So what of the attractive force will be occurred between different, means alag, A for alag, A for adhesive force. So interfacial tension is nothing but the indication of adhesive force. So mathematically we can express like surface tension expressed by the help of gamma. Gamma equals to FB by 2L, where gamma is the surface tension, FB is nothing but the applied force, L is nothing but the length of the surface. Actually, ordinarily, interfacial tension always will be less than the surface tension because greater than the liquid and gas phase exist together. As adhesive force is greater than the cohesive force, that's why interfacial tension will be always less than the surface tension. Okay. So next, so now we are going to discuss regarding different factors which will affect or influence the surface as well as interfacial tension. Means If we will change the environment or condition, then how it will affect the surface tension as well as interfacial tension, we have to know, because from GPAT or NIPER, like you may don't get direct question, but you can get by using this concept, by using this concept. So you need to like understand this concept, means factors how they will affect or influence the surface as well as interfacial tension. First factor, temperature. First factor or temperature. So how temperature will affect the surface tension or interfacial tension, means if we increase the temperature, we are increasing temperature means we are increasing the kinetic energy of the molecule, means as it's getting more temperature means it will be having more energy. More energy means yeah, it will like randomly collide, like it will be having more tendency to escape, means it will break the bond. It will break the bond. If it will break the bond means it will be having more distance, means it will be having lesser tension or force, means it will decrease the surface tension. Okay na? So whenever we will increase the temperature, surface tension will be decreasing. Why? Because now due to increasing temperature, the kinetic energy also will be increased. That will break the intermolecular bonding or force of attraction. Okay, that's the reason. Now this point is very critical and you need to remember properly. Now at the critical temperature, surface tension will become zero. Surface tension, when it will be zero na, at critical temperature. At the critical temperature, surface tension will be become zero. You have to remember this point. Now we'll discuss regarding surface active agent. Now if surface active agent will be accumulated, then it will break the tension and significantly reducing the surface tension. Okay, so surface active agent always reduce the surface tension. You have to remember electrolytes. If we add the electrolytes like salt, like sodium chloride, it the electrolytes always increases, means it will always increase the surface tension. Okay now, next we are going to discuss regarding different surface active agent or surfactant. What is the activity of surfactant or surfactant? What is the action? Now, surfactant or surface active agent used to be accumulated at the interface of surface, and it used to reduce the surface tension. It used to reduce the surface tension, and it will lead to coalescence. Coalescence. Coalescence means it will form the loose cake. Loose cake means it will be preventing from formation of hard cake. So it will improve the stability as well as it will improve the solubility of the product. Stability as well as solubility will be increased. So what are the different surface equations are there? Actually, I took this one from Lieberman Lachman. So try to remember few ones. Different types of surface activation is there. Anionic surface activation, cationic surface activation, as well as ampholytic surface activation. So anionic surface activation, anionic, whenever you will see like sodium, potassium, like this, whenever you will see that will be anionic surface activation. Okay. Whenever you will see like sodium or potassium like this, those are nothing but the anionic surface activation. And cationic surface activation, cationic means quaternary ammonium chloride is there. Means whenever you will see chloride or amines, those are nothing but the our and cationic surface activation. This one is a little bit important one, ampholytic one. Ampholytic surfactant like lecithin. Lecithin, try to remember lecithin. Lecithin is one of the example of ampholytic agent. Lecithin is one of the example of method of measurement of surface and interfacial tension now. So different methods are there like capillary rise method is there, Duino ring detachment method, drop weight method and drop count method. So capillary rise method means force of adhesion between liquid molecule and the capillary wall is greater than the cohesive between the liquid molecule. We know adhesive force means between the different one. Okay. So it is nothing but the force between liquid molecule and the capillary wall, and cohesive means it's between the liquid molecule. When the liquid will rise up now, if the adhesive force means between liquid and the glass or capillary wall is more, generally it will rise and it will weight the capillary wall, spreading over the heat and rinsing the tube. That's nothing but the capillary rise method, and capillary rise method is generally used for the determination of surface tension only. Huh. By using capillary rise method, we used to measure only surface tension. Okay. And what is the formula for like capillary rise method? Gamma equals to 1 by 2 R rho H G. Here gamma surface tension, R nothing but the radius of the particle, liquid droplets, H nothing but the height, rho density, and G acceleration due to gravity. So what is the relation between height and radius? Inversely proportional. As well as surface tension is directly proportional to radius, height, density, and due to gravity, acceleration due to gravity. Next one, Duino ring method. The principle of the instrument mainly depend on the fact that force necessary to detach platinum iridium ring, platinum iridium ring immersed at the surface or interface is proportional to the surface or interfacial tension. So here surface tension is nothing but the directly proportional to dial reading in dynes by and indirectly proportional to ring circumference. So gamma equals to dial reading in dynes by 2 into ring circumference into correction factor beta. And Dino ring method generally used for both measurement of surface as well as interfacial tension. Remaining to like drop weight as well as drop cone also used to measure surface tension as well as interfacial tension. Only capillary rise method used for the surface tension. But remaining whatever methods are there used to measure both surface as well as interfacial tension. For drop weight method, what will be the equation like gamma equals to W by 2 pi r, W nothing but weight, and in case of drop count, mg by 2 pi r nr, 2 pi nr. That you have to remember. Next, we are going to discuss regarding HLB scale. So, actually, from HLB scale, most of the time, one question definitely used to be asked. Uh, hmm, HLB scale one of the most important topic. HLB nothing but the hydrophilic lipophilic balance. It like indicates the lipophilicity or hydrophilicity of any compounds or substances. So actually, it was discovered or by the or developed by the Griffin in 1947. Okay, HL value of the surfactant based on polyhydric alcohol, based on polyhydric alcohol acid esters may be estimated by HLV value equals to 20 into 1 minus S by A, 20 into 1 minus S by A, where S is nothing but the saponification number, A is nothing but the acid number of the fatty acid. So by this using equation, we can calculate the HLE value of any surfactant based on polyhydric alcohol, where S is nothing but the saponification number, A is nothing but the acid number of the fatty acid. Again, we can determine the HLV of surfactant equals to summation of hydrophilic group minus summation of hydrophobic group plus 7. Okay, HL value, you have to remember few like example SLS sodium lauryl sulfate HL value 40, Diagan 13.2, 13.2, T for 13, 13 Diagan, T for 13, T for Diagan. So Diagan will be having HL value of 13.2. Acacia used to like art 8, Acacia 8. Okay, So try to remember these three only: age, value, value. So now we are going to discuss regarding weighting agent. So weighting agent is nothing but one type of surfactant. Means weighting agent will work by reducing the or lowering the surface tension as well as lowering the and contact angle contact angle between the liquid droplets and the surface on which it will spread. Okay now. So suppose this is your surface and you are putting on water droplet. So what this weighting agent will do? Now it will decrease the contact angle between this water droplet and the surface on which it will spray. By decreasing the contact angle, it will it will it will improve or increase the spreadability. So increasing spreadability means it will increase the weightability. Means it will be easily weighted. That's the main mechanism of work of weighting agent. So weighting agent always lowers the contact angle. So when the ideal weighting or complete weighting occur, now if the contact angle will be minimum, means if the contact angle is zero, then ideal weighting or complete weighting occur. And its angle, if the contact angle is 180, then non-weighting non-weighting. Okay. Now different tests are there, evaluation tests are there to test the weighting agent test, like drab test, empiric test, trap test, contact angle method test. Okay. So now we are going to discuss regarding HLV value. So HLV, hydrophilic lipophilic balance. So if low value, if low value lower value, L for low, L for lipophilic, L for lipophilic. Okay na? L for lipophilic. High value, H for high, H for high, H for hydrophilic. Okay ना? So अगर H value high means it will be hydrophilic. If low means lipophilic in nature. Okay? You have to remember these 2 points. So if the value of HLV is between 1 to 3, 1 to 3, then it's antiformic agent. Try to remember this table because you may get definitely one question from this table. Like HLV value will be there, you have to identify which one. Or matching also you can get. Like 1 to 3 antiformic agent, 3 to 6 water and oil, 7 to 9 wetting agent, 8 to 16 oil in water, 13 to 15 detergent, 15 to 18 solubilizing agent. So this must more than enough for this topic or unit. Like this way, again, I will come with another most important topic for GPAT on NIPER point of view. Hope you guys will be beneficial from this video. If you get beneficial, please subscribe my YouTube channel, like, comment, as well as share with your near and dear or friends. So thank you. Stay tuned. Definitely, we are going to discuss on more again. So thank you.